All right, hello YouTube, we're back. Okay, kindly consider the following function. This is a function modeling freefall. You're a grapefruit. The one with the grapefruit. You're a grapefruit. And I'm at the top of a building. And I drop you. What's happening? You fall. Subject to the force of gravity. So you have an acceleration, yes? All right, so let's get a new document today. Let's get a calculator. Whoops, not that. All right, let's say I give you 1,024 minus 16x squared, where x is in seconds and y is in feet. All right, do you see the function? And 1,024 is your initial displacement. In other words, you're starting 1,024 feet in the air. It's a big building. Okay. And so hit enter.
How do you get the calculator to say on top instead of...
On top of what?
Like, every time I click on this, the calculator goes away.
Yeah, well, what you could do is just minimize that so you have two windows going on. Yeah. Otherwise, that's going to happen. Alrighty, now, what happened? Is that a good window? Well, let's say at t equals 0, I drop you. Or in this case, x equals 0 is when I'm dropping. So do you care about negative x's? No. Is that a complete window, though? Let's see. 1,024 minus x squared is a mother function, right? Did you do the mother function dance? Negative x, positive x squared, negative x squared. Absolute value, negative x squared, right? Do you know the dance? What should it look like? Doesn't look. What the heck is that? Parabola. What kind of parabola? Smile? Frown? Okay. So where's the top? Really, really high. Oh, okay. Let's change this window a little bit. How are you going to change the window? I hesitate to do this on the board because it always messes up. Go to menu. Alrighty. And then what? Window? Okay. Then what? You can zoom out. I'm going to do 1 so I can type in my x min, x max, y min, y max that I want. So, do I need a can you have negative time? Well, actually in some contexts that would make sense here, but we don't have negative seconds, we only have negative people. So, let's go this way. And I don't know what x max I want. Remember, this is really time, seconds, right? My y min, well, think of y equals 0 as the ground. So I'm not going under the ground, am I? No. So let's change that. Yeah, if it gets crazy, hit on, hit on, hit on, hit OK, do something, hit enter. Okay. Oh, there it is. Okay. All right, so I want a 0 here. And how high does it go? Or how high does it start? 1,024, right. So you got to have at least that for your y max. 1,000, I guess probably 1,024 is fine. And then let's hit OK. There you go. Now, it's not, this is not a square window, right? The x scale and the y scale are not in the same dimensions. How you look at that? You got it? You don't get it. You good? I did 0 to 10 is good, and then y min, y max was 0 to 1,024. All right. So the scale is a little bit stretched out over here on the x-axis. So, this is 1,024 and this is 10, right? So it's not a square window, what we call a square window, but that's good enough. So now, is that your trajectory? Your one with the grapefruit. What's your trajectory look like? No, that's a parabola. You just said that's not the trajectory, right? You're just going straight down, right? This is just technically t versus h, if you like, where x is time and y is height. So, what I want to know is, let's say after 1 second of fall, now notice how the tick marks are set up. That's 10. What is that? When is it 0? What the y-intercept is, when you plug in x equals 0, you get 1,024. That's a y-intercept. How do you get the x-intercept? When you plug in 0 for y and solve for x, right? So what is it? If you plug in, if you set this equal to 0, 1024 minus 16x squared, what do you get? Well, okay. How about we add another page, and let's solve an equation. All right. So doc, insert, new page, and same problem. Let's do a calculator. What I want to do is solve, menu, algebra, solve, and what was it now? 1024 minus x squared is 16. Sorry, you're right. Ding, 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 ding. 16. Remember, implicit multiply works with constants like 16. That's okay. Okay. Equals 0. Solve for x. What happened? Oh, it's acting stupid. There you go. Enter. And apparently it hits the ground at negative 8 seconds and at positive 8 seconds, right? Well, no. In the context of this problem, the domain is what? Or non-negative. It includes 0, right? So 0 through 8, that's it. You're flying through the air from 0 through 8 seconds, right? Okay. So we know the y-intercept is at y is 1024. We know the x-intercept is at x equals, or the t-intercept is at t equals 8 seconds, right? What I want to know, how do you go back to the other page? That's not really what I want to know, but how do you go back to the other page? Remember? Control back, right? Okay. So if that's 8 seconds, 1 second is like here. I want to know the instantaneous rate of change after 1 second of free fall. How am I going to do that? The instantaneous rate of change at 1 second of free fall. I don't know what this derivative thing you speak of. What is this derivative you speak of? I know not. I know nothing. Wait, let's start from scratch. Yeah. I know nothing about this word differentiate. Yeah?
Find the slope of the tangent line?
Find the slope of a tangent line. Okay. Or, well, how do you do that? That's difficult. But do you know how to get the slope of a secant line? What's the difference between a secant line and a tangent line? Secant line, what? Secant line, no hands here ever? Yeah. It crosses the curve more than once, but a tangent line? Well, technically, it could go through somewhere, but at a particular point, it doesn't cross the curve, right? So I want the slope of the tangent line is what we're going to do. We're going to find out that the slope of the tangent line is the instantaneous rate of change. Okay? Why? Because the limit of the secant line slopes will get us there. All right, let's talk about that. So it looks something like this. Yeah, that's too extreme. Extreme calculus. Okay. Let's say it's h is a function of t. Okay? So I have h of t is 1024 minus 16t squared based on Galileo's freefall model. What? What did he say? I'm not talking about that yet. We'll get there. Okay. So if this is 1, let's see, here's 4, here's 7. What if I take the slope of the secant line between 1 and 7? This line, right here. How do you get the slope of that secant?
Isn't it the f of x plus h minus f of
You're
x
way ahead of me.
straight?
No. You know too much.
Just plug in 1 and 7 is the function.
You need the you need the function values. Okay, you need to know this point, which is at 1 comma something, and you need to know this point, which is at 7 comma something. All right, plug in 1. What do you get? 1 squared, 1 times 16. 1024 minus 16, 1008. Okay. What do you get at? You know what? Let's make it easier. Let's make it easier. Get rid of this. Well, now I'm stuck. I can't do that. All right, all right. Let's make it hard. All right. So now what? Plug in 7. All right, go ahead, do it. You got calculators? You got 500 million computers here. Come on. Come on, go ahead. I can't do everything. Huh? 248? 240? I didn't do it, so I don't have it on here. I don't have it. All right, 240. So what's the slope of that secant line? How do you get slope? Right, delta H over delta T. Now you did y2 minus y1 over x2 minus x1. Don't memorize stuff. Understand what you're doing. All you're doing is finding the difference in the y's over the difference in the t's, x's, or in this case, the difference in the h's over the difference in the t's, right? So what's the difference in the h's? 1008 minus 240. And what's the difference in the time? 1 minus 7. That whole craziness that they made you memorize about y2 minus y1 over x2 minus x1 is because subtraction is not commutative. Duh. What? In other words, don't write 7 minus 1 if you're starting with 1008. Right? Do you see what I'm saying? Okay. All right, so figure that out. Go ahead. You have calculating devices.
Can't we have regular calculator?
It's not toggling. Oh. Do I have to do the toggling? Okay. Oofa. Let's see. Control.
There we go.
Where am I? There you go. All right, so I wanted, what was it? Quantity. 1024 minus what? 240?
1008.
I keep on thinking it's 1024. Yeah, 1008. Okay. Over the quantity. I should have done the controlled divide, shouldn't I? Okay. And what did we say? 1 minus 7, was it?
Yeah.
1 minus 7. Enter. So negative 128. All right, cows, moons, chickens, angstroms, parsecs. Give me some units. The delta H's, the H's are measured in feet, and the T's are measured in seconds. So this negative 128 is in feet per second. It's a rate of change. Okay, slopes are rates of change. Now what I want to do is show the limit as delta T gets smaller and smaller and smaller. Hopefully as delta T goes to 0, what's going to happen? This secant line, I'm going to stay here at 1, but I'm going to move the 7 to 6 to 5 to 4. The secant line is going to get closer and closer and closer to having the same slope as a tangent line. And so this is a limiting process. Okay? Let's say I wanted to do, I don't know, at 4, right here. Let's say this point right here. Give me point. Say that's 4 comma what? Go ahead, plug it in. 4 comma what? Anyone got it? So now the secant line, why is it doing? Looks like this. Wow, my alignment just went completely insane when it was perfect 5 seconds ago. What is that about? My alignment is totally out there. Holy moly. Oh well, pretend that's a secant line. Oh God, what is that? Oh, I can't draw now. My alignment went completely insane. Wasn't it good at first and then went insane? Okay, whatever. The thing is that the slopes of the secant lines are approaching the slopes of the tangent lines, right? Did you get 4 comma what? 768. Okay. So 768. So if you redo this calculation, it's going to be what? Delta H, how do you get it? 1008 minus 768 over 1 minus 4. And I'll cut to the chase. That's negative 80 feet per second. That one, this one's negative 128 feet per second. By the way, what does it mean that it's negative? That's just a frame of reference. Remember, this is a velocity. This is a vector. Not only does it have a magnitude, it has a direction. In this case, negative meaning down. But you're going 128 feet per second, you're just going down, right? So it's negative 128, then it's negative 80, then it's... What do you think it's going to be in the limit? Is it going to get larger in absolute value or smaller in absolute value? Smaller. It's like negative, I don't know, give me a guess. Negative 32 feet per second. Okay, let's find out. Okay, let's find out. Let's write this more in general. Wow, do I really? Oh. Excusez-moi. Excuse. Come on, wake up. Wow. you screw in here? Do I move? And this is on YouTube. YouTube, this is how you calibrate your smart board. Especially if you have a big one. There's a lot more points to calibrate. As you get a smaller smart board, right? Because then when it'll be done already. Alrighty, so what I want to do is I want to come up with a like a formula, a systematic way of doing this, of finding this limit. Okay. So I'm delaying on purpose because it doesn't always wake up right away. It worked. I'm so happy. Okay. For about 5 seconds. Watch. All right. So let me get a graph into here. How about this? So let's get maybe another function around playing around here. How about this one? Right? But it doesn't have to be y equals x squared. Let's make it even more in general. Just any old function that's continuous and differentiable. We'll talk about when it's continuous and differentiable later on. All right, so consider any 2 points on this curve. Say this point and this point. Right? Let's say this point is at some x value, and this point is at what y value? Plug in x and you get f of x. Okay. But now let's say we go a little bit over to the right and we have this x value. If that's x plus, well, isn't it the delta x that we were playing with a minute ago with the slope, right? Okay. And if this is y, this is going to be y plus delta y, right? But if I plug in x plus delta x into f, what do I get? What's this y value here? F of x plus h. Okay. So now let's do the slope from this point to this point. Again, a secant line, right? How do you get that slope? I'll start you off. How about, do you know the coordinates of this point? X plus delta x, comma, f of x plus h. Do you know the coordinates of this point?
Yes.
X, comma, f of x. So if I start off like last time up here, I have f of x plus h. How do you do your delta y over delta x? Minus f of x all over. What's the x value that goes with f of x plus h? Because subtraction is not commutative. X plus delta x minus this guy's x is x. Okay, so what happens to the x's down here? They go. I like it. They cancel, but they go. They go away. All right. And oh, I did bad things. Because you said it and I'm listening to you. Why do I listen to you? X plus delta x. All right, now, you can write delta x all over the place all day long, but it really gets to be, it gets old really fast. Okay. So, I don't know if you noticed, but they don't call it delta x, they call it h. So, to make it simple, we're going to write h's instead. But now we want to take the limit as delta x goes to 0. As this distance from here to here gets smaller and smaller and smaller, the delta x is changing, not the x. This is getting smaller and smaller and smaller. This point up here slides down the curve, and the slopes of the secant lines get closer and closer to the slope of the tangent line. In the limit, that's what you get, the slope of the tangent line. That's the derivative. The slope of the tangent line is the derivative, right? Right? So I'm going to say that, let's simplify this a little bit. F prime is the limit. Now let's call it, instead of delta x, so you don't have to write a lot. H goes to 0 of f of x plus h minus f of x all over h. So let's say that's our definition of the derivative, the instantaneous rate of change, the slope of the tangent line at a given point on the curve. Right? All right. So now let's answer the question. What was the question?
Let go back and
Are you going to go back? Okay. Well, the question was, how fast is the grapefruit falling after 1 second of free fall? That was the question, right? That was sort of hard to do this way, because you're really not going to be able to do, plug in all these points, millions and zillions and infinitely many points close to this. That's hard. So I'm going to do it this way. Let f of x equal 1024 minus 16x squared I mean, it doesn't have to be y and x all the time, right? It could be h and t, whatever, but just to be nice. So what's f prime of 1? Let's find out. Well, we said that f prime of x is the limit as h goes to 0 of f of x plus h minus f of x all over h, right? So, what is f prime of 1? In other words, x is going to be 1 from now on. When f is this, can you rewrite this in terms of that function? This is a general statement for all differentiable functions, right? Can you write it specifically for this function at this point? That's what I want. So, how do you write f of x plus h? Well, x is 1. And f is 1024 minus 16x squared. So in place of x, what do you write?
1 plus h.
1 plus h. Because this is a composition. Remember composing function? F of x plus h means take x plus h and plug it into x, into f of x, right? So I'm going to write the limit as h goes to 0 of 1024 minus 16 times 1 plus h squared. That's this thing, plug in 1 plus h. I'm finding the derivative at the point. I'm not finding the derivative function yet.
Wait, why did you plug in 1 first? Why didn't you first plug x plus h into the function?
You could do it either way. I'm showing you two different ways. This is called the derivative at a point, actually plugging in a number right away. You don't want to plug in a number right away, you don't have to. And you'll get a general derivative function at every x, then plug in 1. Either way. I'm going to do it both ways. Let me do it this way first and I'll show you the other, right? So take that whole statement, f of x plus h, all of that minus what? The function itself, right? Which is 1024 minus 16x squared. This whole mess. All over, don't forget all over h. Okay. Boom. Oh, I didn't plug in the 1 over there, right. Whoops, I meant to plug in 1 for x everywhere, right, you're right. Okay, good. So let's simplify this stuff. Now, we figured this out before. Didn't we plug in 1 already into the function? We got 1008, wasn't it? That's 1008, is it? Okay. What are you going to do with this 1 plus h squared thing? Expand it. Okay. In other words, well, it's just squaring, so you could foil it, but you know the binomial expansion theorem?
Yeah.
1, 2, 1. Pascal's triangle? Anyone here with Pascal's triangle? 1, 1, 1, 2, 1, 1. 3, 3, 1, 1. 4, 6, 4, 1. Right? That? You can use that to expand the binomial? Right? Okay. So I want the limit as h goes to 0 of 1024 minus 16 times that. Well, it's 1 plus 2h plus 1h squared. Yes? 1, 2, 1. 1, 2, 1. Foil this out. Yeah, the 1, 2, 1. You got 1. Let's see, how does it go now? You got h squared, 1 to the 0. Then you got h to the 1, 1 to the 1. Then you got h to the 0 and 1 to the 2 times the 1, 2, 1. Right? For foil it, it's only squaring.
Yeah,
Big deal. Okay, minus this stuff. Well, we said it's 1024, right?
Oh, okay.
Okay. Well, you know, doesn't it cancel the 1024 directly if I leave it like that? I'm going to leave it like that. All over h. All right. What did I mess up now? Well, what? Let's distribute what, the 16? Yeah. But remember, how do you subtract? You never do. So add the opposite of 1024 to 1024. Poof. Okay. And then add the opposite of negative 16. How do you add the opposite of 16? Negative 16. You're really adding 16, right? Okay. So all I got to do is take this negative 16 times this thing and add 16 and then divide by h. Did I mess up something? Whoops. So you still got to distribute? Okay. So distribute the negative 16, you get the limit as h goes to 0 of what? Negative 16 minus 32h minus 16h squared plus 16. And what's nice about that is that the 16s cancel. and you get your limit as h goes to 0 of negative 32h minus 16h squared over h. And what's nice about this is what? You can factor out the h's in the numerator and cancel with the denominator, and you're left with the limit as h goes to 0 of negative 32 plus 16h, that's a 3, minus. Now notice why this is important. Because before this, all of these statements, was this a plug-in limit? Can you plug in 0 for h? No. But what did we do? We got something that simplifies to the point where you can plug in 0 for h. This is a plug-in limit. This is a continuous function in h. So plug in 0 and you get negative 32 feet per second. Was that the guess?
Yeah.
That was the guess. Was it really a guess, or did you differentialize? Yeah. Okay. Did he cheated, right? You cheated.
I didn't cheat.
No, you didn't cheat? All right. Let's cheat. Ready? This is cheating because we haven't developed the algebraic rules for differentiation yet, but you know them, don't you? What's h prime of t? The derivative of a constant? I heard like 3 different numbers. 0. Right? Because think of it as 1024 times t to the 0 and do the power rule. How does the power rule go? Bring the exponent down, 0 times anything, right? Or if you graph y equals 1024, what do you get? Mother function. Horizontal line always has a slope of 0. So any tangent line you draw there has a 0 slope. That's a derivative everywhere, right? So if you're differentiating this, you get 0 by power rule. If you're differentiating this, you get 0 by horizontal line. What about the power rule here? Bring down the exponent times whatever was there, and subtract 1 from the exponent. There you go. So what's h prime of 1 second after all? Same thing. Okay.
Why did you do it the other way at all?
Because this comes from this. You can't have this without doing this first about 500,000 times. Which is what we're going to do for the rest of the week, next week. Okay. Okay? So, yay. Now, we're about out of time, aren't we? Because we did our little YouTube. All right, we'll continue this discussion on Monday. Don't forget your homework. Page 92, multiples of 5, due Monday. All right, so let's leave it at that. And YouTube, have a nice day.